In this section, we're going to be learning how to solve exponential equations and log equations. The first type of problem that we're going to solve is this exponential equation, and in our directions it says to use logarithms to solve the exponential equations. So the first thing that I want to do is I want to get this exponential portion on a side by itself. So in order to do that, I first need to subtract 7 from both sides. So now I have negative 5 raised to the 2x minus 1 is equal to negative 3. Now I also have this negative that I need to get rid of, so I'm going to divide both sides by negative 1, which gives me 5 raised to the 2x minus 1 is equal to 3. So now in order to get rid of that, I need to add log to both sides. So when I do that, I now have log of 5 raised to the 2x minus 1 is equal to log of 3. Now, based on my log rules, this 2x now can come down to the front. So 2x minus 1 is now being multiplied with log of 5 equal to log of 3. So in order to get rid of that log 5, because I want to solve for x here, I need to divide both sides by log of 5. So now I have 2x minus 1 is equal to, so I need to compute a value for this. So in my calculator, I'm going to do log of 3. So I'm using the log function that's right beside number 7. But I need to make sure that I use parentheses. So log of 3 divided by log of 5. Notice my use of parentheses gives me this solution. So what I'm going to do is I'm going to write this as a rounded decimal. So once I have put down my solution here, notice I have a nice equation. So I'm going to add 1. So since I still have it in my calculator, I'm just going to do the rest in my calculator. So I'm going to add 1 to that, so plus 1. And then since I have this 2 here, I need to divide both sides by 2. So my solution is 0.8413. So I added 1 and divided, so my solution is 0.8413. So now, for a few more examples. So for problem number 1, I'm solving the equation and I need to round to the nearest hundredth. So I'm going to add log to both sides. When I do that, my rules say that my exponent can come to the front. So x times log of 2 is equal to log of 5. So since this is being multiplied, I now need to divide both sides by log of 2 because I want x by itself, which is now what I have. Now I need to compute a value for log of 5 divided by log of 2. So in my calculator, I need to carefully put this in. I need to have parentheses first, log of 5 divided by log of 2. So my solution, in my directions it says to the nearest hundredth. So here I have tens, hundredths, so I'm rounding to the 2 decimal places. So 2.32 is my solution. So for problem number 3, I already have my exponent on the side by itself. So I need to add log to both sides. Now my properties say that this exponent of x plus 1 can be moved to the front. Now, notice that I put parentheses around this to show that it's being multiplied with log of 5. So I'm going to divide by log of 5 on both sides. I'm now left with x plus 1 is equal to, and I need to compute a value for log of 25 divided by log of 5. So log of 25 divided by log of 5 gives me a solution of 2. So now I'm going to subtract 1 from both sides. So x is equal to 1. Now problem number 6 is similar, but I do not have my exponential portion on the side by itself. So I need to add 5 to both sides first. So I now have 4x is equal to 8. Now I can add log to both sides and move my exponent to the front. So now I need to divide both sides by log of 4. So I'm left with log is equal to, or excuse me, x is equal to log of 8 divided by log of 4, which gives me 1.5. So notice that problem number 11 is similar to the problem I just did. I need my exponential portion on the side by itself. So I need to add 1 to both sides first. Now I need to add log and move my exponent. So 2x plus 7 comes to the front of log of 5 equal to log of 9. So I now need to divide both sides by log of 5. When I do that, I have 2x plus 7 is now equal to, and I'm going to compute a value for log of 9 divided by log of 5. So notice I need to make sure that I have parentheses on the top and the bottom. Gives me a solution of 1.365. So now I'm going to add 7 to that value. So 2x is equal to 8.365. Excuse me, I don't need to add 7, I need to subtract 7. So let me fix my mistake. So it was already plus, I need to subtract in order to get rid of it. So I'm going to subtract 7 from that value. Gives me minus 5.634, and I'm dividing that by 2 to get x by itself. So x is equal to negative 2.82, because it said to round. The 7 rounds the 1 up to 2. So now, that was writing or solving my exponential functions by adding log to both sides. The second type of problem is solving my log equations. Now these are a little bit easier because I can use my circle rule. So notice for problem number 13, I don't have a base written, so it's understood to be a base of 10. So if you would like, you can rewrite it as log base 10 of x is now equal to 2. So now I can use my circle rule. 10 to the second power is equal to x. 10 to the second power is 100. So x equals 100 is my solution. For problem number 14, it is the same type deal. There's no base written, so it's understood to be a 10. So that becomes 10 cubed is now equal to 3x. I can compute a value for 10 cubed in my calculator, which gives me a value of 1,000, is now equal to 3x. I'm going to divide both sides by 3. So when I divide by 3, it gives me this decimal, and I'm going to do math to a fraction, which is just going to leave my answer as 1,000 divided by 3. Now in my instructions, notice it says to round to the nearest thousandth. So I cannot leave my answer in fraction form. So my answer should be 333.10 thousandths. So I need 3 decimal places as my solution. So based on my instructions, this is my solution. Had it said that I could leave it in fraction form, then I could leave it as 1,000 over 3. Problem number 15 is the same type problem. However, I cannot use the circle rule because I have this plus 2. So I need to get rid of the plus 2 first before using my circle rule. So I'm going to rewrite the problem now with the base of 10. Because I still have a base of 10, I just need to get rid of the 2 first. So 6 minus 2 is equal to 4. So now my circle rule leaves me with 10 to the 4th power is equal to 2x. 10 to the 4th power gives me 10,000. 10,000 divided by 2 gives me a solution of 5,000. Now, for problem number 16, I need to subtract 5 from both sides first. I'm left with log base 10, if it's not written, plus 1 is equal to 1. So 10 to the 1st power is equal to 2x plus 1. 10 to the 1st power is 10. So now I need to subtract 1 from both sides. 9 is equal to 2x. Divide both sides by 2. X is equal to 4.5. So, if my function starts with 1 log, then I need to use my circle rule in order to solve. If my function starts with an exponential, notice there's no logs in the problem the way they started, then I need to add log to both sides and solve for x.